Welcome to the fourth webinar on MySQL. Today's topic is transaction. And next week, we are going to learn stored procedures and functions. And the following week, we are going to learn triggers and scheduled events. So let's move on with the presentation. So these are the set of topics that we are going to cover. We'll talk about what is a transaction. We'll look into what ACID properties mean. And we'll see transaction support in MySQL, and we'll learn the concept of save points, and also we'll spend some time on isolation levels. There are 4 different isolation levels, and we're going to look into each of those. And finally, table logs. So what is a transaction? Transaction, I assume everybody is well aware of, a set of database manipulation operations is performed as if it is a single work unit. For example, if you transfer $100 from your savings account to checking account, that transfer is actually made of 2 update operations. Update savings table and update checking table. So it's going to withdraw $100 from savings table, and then it's going to deposit $100 to the checking table. And these 2 operations need to be performed in a single unit. If you have a failure in the middle, and if it is not performed in transactional manner, and then there will be a problem. ACID properties. So ACID stands for atomicity, consistency, isolation, and durability. So atomicity ensures that all operations within a single unit, work unit, is completed successfully. Otherwise, the transaction is aborted at a point of failure, and all previous operations before that failure will be rolled back. And consistency means that database should be in a consistent state, and in fact, the state changes only when successful commitment happens. Isolation ensures that transactions, multiple transactions, operate independently of and transparent to each other. And again, we are going to see 4 different levels of isolation later on. Durability means that even if there is a system failure, the result of effect of committed transaction persists. So this ACID properties is a gauge how transactional a particular system is. So in this case, we are talking about ACID properties from the context of database. So let's talk about transaction support in MySQL. As we talked about last week, only InnoDB storage engines support transactions, and other storage engines ignore transactional statement. So the way that you are going to start a transaction is using this statement, start transaction. Again, this is only applicable to InnoDB storage engine. For committing and rollback, you are going to use commit statement, and for rollback, you are going to use rollback statement. So this is an example. So here you're going to say start transaction. From that point on, the whatever database operation you are going to perform is going to be in transactional context. So here we are going to insert a user, actually 2 users, to a person table, and then you are going to say commit. So this table, the person table, will be changed only when you are going to say commit. Okay? Until you say commit, the actual database table will not be updated. So in this case, because you commit, the table, person table, have these 2 users after commit. On the other hand, if you say rollback, and then this table should have no impact. There should be no the additional records of these 2 users because you roll back. All right, so let's do a few exercises. Exercise 1 and exercise 2 and exercise 3. So let's take a look at the lab documentation. So exercise 1, we're going to try commit, and exercise 2, we are going to try rollback, and then exercise 3, we are going to try InnoDB storage engine and other storage engine and how transactional behavior is supported. All right, so we are going to set things up. We have to start MySQL which I've done already, and then we have MySQL shell. So we are going to use MyDB database, and then we are going to create checking table and savings table. Okay, so we created a checking table here, and then we have a savings table, and then we have added two users, Sang Shin and Bill Gates, and so this is savings. So on the checking account, both myself and Bill Gates has, well, actually he has more money than me, so I got $1,000 and he has $2,000. And in the savings account, I got $100 and he has $100. All right, so we're going to execute this SQL, which I've done that already here. So we should have a checking table. My apology. All right, so we see two people, me and Bill Gates, 1,000 and 2,000 each, and the savings table, $100 each. Now we're going to start the transaction. The way that you can set the transaction is either using global isolation and the TX isolation. So we can actually take a look at both of these global variables. And for now, as the isolation is set repeatable read, and the local isolation is also repeatable read. Okay, so we're going to talk about this one later on when we talk about isolation. This is a default isolation level. Okay. So we are going to start the transaction. So here we are going to start a transaction, and then we are going to update the balance of the Sang Shin of checking table to 250. Okay, so we are going to update. And anybody whose name is Sang Shin will have his balance to be changed to. It's actually the balance is going to be subtracted by $250. So we're trying to transfer $250 from Sang's savings account to his checking account. All right, now we are going to add that $250 that we withdraw from checking account to savings account. So we're going to actually update. And right now, if I see the table, it reflects the changes I made. However, if you take a look at the actual table, the table should not have been changed. Okay, so this is actually from memory space. Okay, so we are going to open another terminal window. So I'm gonna just make this one smaller. Like so, this is the client 1, and then we are going to create client 2. So I have to go MySQL. Okay. And I'm going to start MySQL. Okay, so let me just move this one a little bit higher here. Okay, so we are going to set, yeah, so this is the default anyway, but let's just take a look at that. So default is the repeatable read and repeatable read. Again, we have to choose default database on this client. So database is using MyDB. Now, if I take a look at the checking table, this client should not see any changes that is made by the client 1, okay, because things are not committed yet. Okay, same thing for a savings table. No change. Okay, so now we're going to actually go to the client 1, then we'll actually commit. Okay, so we commit. Now, if we are going to go again, the commit. Now the table should really reflect the changes that we have made. Okay. So we're going to go to the second client. Okay. Now we're going to actually see the savings, and you can see the changes reflected. So the client one change made by client one is now reflected in client two as well. Okay. So the checking account should actually reflect the same thing. Okay. All right, as expected. Okay, so we are going to exit the client two. All right, so we're going to just leave it for now. So that's commit. Now let's try the transaction rollback. Okay, so we are going to again start from scratch. So here we are going to. So we are going to now should start. We create the table. So here everything is back to the starting point. Okay. All right. So here I'm gonna just make sure we'll just exit and try again. Okay. All right. So we're gonna start the transaction here. So this time we are actually trying a rollback. Okay. So same sequence of operations, but this time the client one, instead of doing commitment, it will do rollback. Start transaction. And again, we are going to try the update checking. And, okay, I'm going to just copy. Oh, this time we're actually changing Bill Gates. Okay, so we changed the Bill Gates savings checking account, subtract $250, meaning withdraw $250 to Bill Gates checking account. Now we are going to add $250 to Bill Gates savings table. And then where? Okay, now if I take a look at the memory of this checking table, that should actually reflect the change that we have made. Okay, but the actual table should not be changed. Okay. All right, so we are gonna and then we're gonna actually perform rollback here. Okay, so client two shouldn't actually see any the client two should not see any changes anyway. Okay. Okay, no changes. And here rollback. Okay, and then this user should not actually see any changes at all because it's rolled back. So even in memory image of the table, the things are rolled back. Excuse me. All right, that's a rollback. So yeah, I think that's actually, yeah, so basically rollback. Exercise 3 is we are going to actually try, what we have done so far is actually with the InnoDB storage engine. So you can actually certainly see show, as we learned last week, show engines. And then you should see InnoDB is the one that supports your transaction. And basically, we are using InnoDB as a default storage engine. And so, we can see, we were able to see transaction and rollback and commit. Those statements are being honored. Okay. So this is another testing. Now, this time we are going to actually create a table using the MyISAM instead of the InnoDB. So I'm going to create table. Okay. And then let's try to start the transaction. and then we insert. And okay, and then we can take a look at the table. And obviously, at this point, because my ISAM table does not support, my ISAM store engine does not support the transaction. Whenever you insert it, it will actually insert it into a table. Okay, so this is actually what gets reflected in the table. Okay, so you cannot roll back here. So if you try to say roll back, you're gonna actually see some warnings. There's a one warning. So let's try one rollback, and there is one warning. And if you try to see warning, show warnings, you can see warning. Some non-transactional changed tables couldn't be rolled back. Right? So if you in fact see the table is reflected with a newly added the record here. Okay, so that is what happens with yeah. So again, if you see the table, you actually see the values. Even if you did the rollback, because the rollback is not honored. Okay, so that is a simple commit and rollback, and we take a look at the InnoDB and MyISAM, the story engines, how they actually support transactions. Okay, save points. The save point is basically user-defined points within a transaction that can be used for partial rollback. Okay, so instead of actually rolling back to the starting point, you can actually set save points. And when you say rollback, and if you specify the name of the save point with to save point, it will be rolled back to that save point. So reverse all changes made after that save point. So this is an example. So let's say we start the transaction, and then we made one change. We inserted one person into person table, and then we create a save point. So we say save point, and you give a name. Okay, so I just give a name person 31. So basically, I'm actually making a save point, whatever change I made up to this point after starting a transaction. And then I added another person, and then I create another save point. Oh, so this is a case that I didn't make a save point. Here I can say just roll back to save point person 31. So when I roll back, so the changes that will be made is that this change, I'm actually adding another user, but I did a rollback to this point. So once you've done that, sorry about that. I have still terrible cold, so my voice is pretty bad. So here, when I roll back to this point, this person should be still be in the memory table, but this user should not be there. Okay, so let's try save point. So you can certainly find out save point help, and so let's start the transaction. Start the transaction, and we are going to add this person and values and Hannah. Looks like yeah, looks like a table is not actually correct. Yeah, my apology. Yeah, so I should actually change these things. Okay, so I'm gonna just use a p name in that case. Person ID and t name and values and 31. Okay, so now we'll do save points. Point person 31, and then if you see select from person, we should see that person just added. Okay, now we're gonna insert the second person. So and values and 32 and John. Okay. All right, so now we're going to actually try save point. So what we have done is that we added two people. Oh, we have to actually, okay, so I'm not going to make any other save point, and I'm going to actually save point to this one, person 31, okay? So if you see the table right now, we have two people added, right? So I'm going to roll back. So I'm going to roll back here, roll back, and to save point, person 31. Okay, now if I see the table, and we should see only one person, and the second person I added should not be there. Okay, so that is basically save point. All right, so that is that. So let's move on to isolation levels. Transaction isolation levels. There are 4 different isolation levels supported by MySQL, and actually pretty much all the database servers out there. Read uncommitted and read committed and repeatable read and serializable. So isolation levels basically provides the level of isolation. The higher level of isolation will actually give you least performance. Okay. So this one is the lowest level of isolation, and serializable is the highest level of isolation. So because it's the lowest level isolation, this is supposed to give you, this gives you the best performing database operations, okay? Because more multiple people, more number of actual clients can actually access the table. Serializable actually provides the highest level isolation because everything is serialized. However, it will give you a least the worst performance. Okay, and read committed and repeatable read is in between. So let's start with, by the way, repeatable read is the default isolation level, as we have seen before. So let's take a look at the read uncommitted isolation level. So the problem of this isolation level is that it could give you what is called a dirty read symptom. What it means is this: suppose you have a client 1. Client 1 start the transaction, and then client 2 also start the transaction. So client 1 then insert a record, meaning make a change, whatever change is, insert or update, delete or whatever. Okay. Now in read uncommitted isolation level, the other clients can see the change right away. Okay. So here the second client can see the change that is made to record A. So in fact, this is a dirty read because client 1 can actually roll back. So client in fact roll back, this change is gone, okay, and then the second client does not see the record anymore. Okay, so this is called the dirty read because this is the change that has not been committed by client 1. Okay, so this is the dirty read symptom of read uncommitted isolation level. All right, so let's do the first the read uncommitted exercise. So we are going to start person data table again. Yeah, so we're going to actually drop person, drop table person. Okay, so I'm going to just start it again, just to be a clean state. Using my DB. Okay, and then we are going to create the brand new table. Can I delete update parent? Okay, so I'm gonna just throw up database MyDB. All right. And let's try to. Okay, good. So in the clean state, and if you see the person table, so this is the one, and then we can see there are 5 entries in the person table. Okay, so this is actually what we are trying to simulate. Okay, so we have a client 1, so this is a client 1, and this is a client 2. Okay, so client 1, we are, oh, by the way, yeah, so this is actually, so we are going to actually see, we are going to use the information schema database. So that's the table, that's actually built-in system level table that is used to support this, the isolation levels. Okay, so I'm going to use, oops. Yeah, so I'm going to actually use this one. And use okay, information schema, and then we are going to see the global and localization levels. So is the isolation level is repeatable read, okay, as a default. Okay, so we're going to change transaction isolation level, global transaction isolation level to read uncommitted because that's what we want to try. Okay. Okay, now if you see global isolation levels is now actually changed. Okay, so now because its global isolation level has been changed, any client that gets actually started will have the both local isolation level and global isolation level to be read committed. Okay, so you can change this one to read committed as well here, but we can actually try brand new client just to start from scratch. Okay, so we have a client number 1. Now, if I take a look at the isolation, yeah, so both of them read uncommitted and read uncommitted. Okay, all right, so we're gonna use again, use MyDB. Okay, all right, so client 1, now we're gonna start the transaction. Okay, start the transaction. And then, we can take a look at the person, and this is something that we have created before. So we should have these 5 people. Okay. Now we're going to start the brand new transaction in client 2. So I'm going to again exit out and start again. And we can certainly see the isolation levels, both local and global, like this. And now both of them are actually read uncommitted. Okay. All right. So again, I have to use my DB. So we have 2 clients. Both clients are actually now using read uncommitted. Okay. So here, if I see the table person, it should have the same information as the client 1 sees because we haven't made any changes. Okay. So both of them actually start the transaction, but nothing has been changed. So now in client 1, we are going to add a new person. So here, I'm going to go to client 1. Now, read uncommitted level, whenever I make a change, okay, to the table, that should be visible to the second client right away, even though the client one has not committed. Okay. All right. So now, if I take a look at the table, I mean, the Tom has been added. Okay. All right. Now, in read uncommitted, this is the second client. We'll actually read this change. This is the dirty read because this has not been committed. So this first user could actually roll back, and then the second user will not see it. So we are going to go to the second client. So let's try to read person table. Now you see it. Okay, so this is dirty read. Okay, so now I'm gonna go to the first client, and now I'm gonna do rollback. So this Tom should be removed here. So no Tom here, okay, because we rolled back. And now if I see here in the second client doesn't see that either, okay? But the thing is that second client, even before the first client commit or rollback, the second client see that change, and this is called a dirty read because it's not really clean, okay? So it's a dirty read. So this is an example of the read uncommitted example. All right, so let's move on to the next level. Next level is read committed isolation level. So here, this is a little bit better than the read uncommitted. So committed update in one transaction is visible within another transaction. Okay, only when the first user in fact committed. Okay, so let's say these two clients start the transaction, and the first client make a change. Okay, in read committed level, you don't see the change. Okay, and however, when the first user commit, then the second user will see the change. Okay, now in this case, the problem is the second client see two different results for the same query. Okay, so that is it's actually return different results for the same query. So that's a little bit inconsistent. Okay, so this is a read committed isolation level. So let's do that. Okay. So we are going to set global transaction. Okay, it's changed. So if I see this one, so global is changed, read committed. Okay, so we are going to actually start it again so that we can actually have local transaction isolation level is the same as the first one. Okay, so if you see, okay, so both of them are read committed. Okay, so client 2, so we'll do the same thing. We'll just X out and try again. And if I see this one. Okay, so both of them are actually read committed. Okay, read uncommitted. Read committed, I'm sorry, yeah. Okay, so now we're going to actually do the same thing. Okay, so here we are going to we have seen this one. So again, we are going to use MyDB, and we're going to use MyDB. Okay, and so we're going to start with the transaction in the client 1. So we go to start transaction in client 1. Okay, and let's take a look at the table. So we see 5 people there. And the client 2, same thing. So we're going to start transaction. Again, start to see the same records in person table. Okay. Now, client 1 is going to add a new person. So making a change to a person table here. And values. And then add this Tom Jones. Okay. All right. So if you take a look at the person table, time has been added. Okay. Now, if you go to the second user, okay, you're not going to actually see the change because the first user, you don't see Tom here. Okay, so this is a difference from read uncommitted, the first one that we look into. Okay, so until the first person committed or rollback, if the first client rollback, then he's not going to actually see any change. However, here if you say commit, okay, and then in the second user, you're going to see the change, Tom Jones. Okay, so the problem of this isolation is that performing the same query operation, you see two different results depending on the first client when the first client in fact performed the commit or rollback. Okay, so that is the read committed the isolation level. Okay, so we just saw that. All right, the third one is the default. This is repeatable read isolation level. So in this case, the changes in one transaction, in this case client one, is visible in another transaction only after its own commit. Okay, so let's say client one start the transaction and make a change, insert record A, and of course, just like in previous read committed, the second user should not see it, and then commit it. The second user still don't see it because until the whatever query operation is going to be still consistent. Okay. Now, when the second user commit, and then the second user will actually see the change. Okay. All right. So let's do this. So we are going to change. And let's see. Oh, yeah, because we haven't changed. Yeah, we have changed it. We have to actually set yeah, let's actually create the database table first. Okay. All right, so now we are going to actually set the repeatable read. So this is the default, but since we have changed to the read committed, if you actually see, we are still in the read committed. Okay, so we want to actually change this one to back to, read committed. So we want to change it back to repeatable read. So we're going to change global transaction isolation level to this. Okay, and then you can see it's now change repeatable read. Okay, so if you just get out, and again this one get out, and now both of them, both client should have repeatable read, both global and the local transaction isolation level. Okay, so let's take a look at the this. Okay, so repeatable read and both. Okay, so let's try that. Okay, so this is a default. Okay, so again, we are going to use MyDB. Use MyDB. And for this one, since client 2, MyDB. Okay. All right. So now in the client 1, we are going to start the transaction. So start the transaction. And if you take a look at the person table, because we created the table from scratch, we're going to see 5 people here. Okay. And the same thing in the second client. We should actually see, we're going to start the transaction first. And if I see from person, yeah, so both of them actually see the same data. Now in the client 1, we are going to make a change. Okay, so we are going to add a new person, Tom Jones. And values. And then of course we are going to see 6 people here. Okay, so Tom Jones is added. Okay, then we go to client 2. The client 2 shouldn't actually see any changes, okay, until it's on commitment. So here, even though the first client commit, okay, the second client should not see the change. Okay, so this is the difference from read committed, the second level that we saw previously. Okay, now, excuse me, the second user will actually see the change when he commit himself. So now if I take a look at the table, now this user, second client, see the change. All right. So that is repeatable read, which is the default. It actually provides the most consistency as well as the higher performance. Okay, good performance. The last one is serializable. So serializable, everything is serialized. So transactions are serialized, and in practice, it's not used because it actually gives you the very low performance. Okay. So until previous transaction ends via either commit or rollback, the database operations in other transactions are basically blocked. Okay. So client 1 start the transaction, and whatever operations until commit, the client 2 cannot do anything. So once the client 1 either commit or rollback, and then client 2 in this case can do whatever database operations. Okay. So when you perform the select operation, it's going to be blocked. Okay. So let's do that exercise. All right, so we are going to change global transaction to serializable. Okay, and we can get out. This one get out. Now we're gonna start the new transaction. Excuse me. All right, now if I see the transaction, yeah, it's actually changed to serializable. Same thing here. Okay, serializable. Okay, now what you're going to do is on client 1, we are going to start the transaction. Okay, so start your transaction. Okay, and client 2 also start the transaction. Okay, first of all, you want to use MyDB. Use MyDB, and then start transaction in the second client. Okay, now first client is going to add a new user, is making a change. Okay, and values and Tom Jones. Oh, okay, so it looks like we have already a table, so I'm going to just change to another user. Values and so I'm going to use 43 and Tom2, John's 2, age 430 years old. Okay. Okay, so now we have added Tom2. Okay. Now if I so that's now if I try to so I go to client 2. Okay. And then like this, you can see it's blocked. It doesn't return, okay, until the first client either commit or rollback. Okay, so this time let's try rollback. Okay, now the second client, operation is performed. Okay, so that's serializable. Okay, moving forward, table logs. So it's probably not that much important. So for non-DB storage engines, every change is immediately saved to disk, as we talked about. So it's not suitable for multi-user environment where transaction behavior is essential. However, for those database, the storage engines, table logs could be actually used to simulate these transactional properties. Okay, but table logs are not as fine-grained as read, row log or page set of rows log. Okay. So table locks, you can basically lock the table in two different modes, read or write. Okay, so again, this is used only for non-DB, non-transactional based storage engines. So it's actually rarely used. Anybody can read. So read table log is that anybody can read data from the table, but nobody can make a change to the table until log is released. Okay, so the way the syntax is log table and person table and read, and this is for locking and this is unlocking. Okay, and write table log is client who issued the write table log can read and make changes to the table while other people cannot read. So in previous case, read table log, other people can read. In this case, other people cannot read while other people cannot write until log is released. Okay, so this is the syntax. All right, so I'm gonna actually just kind of show you how, basically we're using my ISAM storage engine table, and basically, we are basically doing a locking. Okay, so lock table and insert. In client lock the table, try to insert the law unlock the table. Yeah, so it's basically a table is locked with a read lock and it cannot be updated. Yeah, so if you try to update it, basically you cannot do it. Okay, it's actually only for read operations. So unlock table. Write log is that so in this case, the first client try to update and select, just see the change, and client two cannot actually do the change either. So until the first client is actually doing unlock table. All right, so yeah, so this is again, probably not that much important because this is only for non-DB. All right, so I have to actually leave. We got only 13 minutes, and I have to leave because the